Well, good afternoon or good evening. I never know what to say around 5 o'clock. But hi, thanks for showing up. Welcome to Mirror Mirror, Reflect the PDF Attacks Against or Using SQL Injection. My name is Shawn Asmus, and with me is Kristov Widak, who's my tag team partner today. We both worked on this presentation together. We're both application security consultants with Fishnet Security. Today's agenda, we'll be doing a little bit of gearing up on what this talk's all about. We'll cover a little brief history. Too much history is a bad thing. So what we'd like to focus on today is a case study based on a real-world pen test that I was involved in. We'll do an awesome demo for you guys, setting that up for success, and then summarize at the end, obviously. So at any point during this talk, feel free to throw up your hand, raise a question or comment. We'll, if we like your question, we'll try to answer it. So what we're not going to talk about, or what the talk isn't about today, we are not disclosing anything like a new way to escape PDF syntax. Okay, a lot of research has already been done, a lot of great research, and we actually include a lot of reference at the end on that research. If you're not familiar with what we mean by PDF escaping, we'll give you some examples through this presentation, but we include references at the end. Same thing with SQL injection. If you're not all that up to speed on what it means to execute SQL injection against a website, we've got some great references at the end. But back to what it isn't, we are not releasing an O-Day or a new flaw in a particular vulnerability or a particular version of Acrobat Reader or other PDF reader. We are also not rehashing some of the additional pretty interesting research on how to use cross-site scripting attacks to launch SQL injection attacks. However, with some of the techniques that we will be covering, not specifically in our presentation, but towards the end, we actually have a tool that will eventually, it's not quite there, but we will eventually go the opposite way, how to use SQL injection to launch cross-site scripting attacks. So, of course, why SQL injection? Why are you here? Obviously, it is of some interest to you, but why is it relevant? You know, wasn't this fixed, last decade? And apparently not, right? There's still a lot of it out there, and I'm going to hand the mic over to Kristov.
Sure. So just something that was in the news recently. Did anyone hear about the Deeds and Yahoo Voices compromise that happened? See some? No. So there was some group that they doxed Yahoo Voices. They through some type of SQL injection attack, they extracted a bunch of credentials from one of the Yahoo sites, and they disclosed 453,000 different credentials, and showed that Yahoo has some pretty weak password policies. Now, Yahoo came back and said, it's not a problem, only 5% of these accounts are still active. We're going to close this out, but it's not interesting. You got into our database, but there's nothing there, so big deal. Now, what we want to talk about in this presentation is, okay, maybe you have a SQL injection in your application with a database that doesn't have something interesting in it. But can we do other things with that SQL injection attack that might be of interest to an attacker? And I would argue for any kind of trusted website, you can do some of that. So we'll be talking about that later in the talk.
Okay, that was kind of an awkward segue or getting out of the way type move. But anyway, so a little more history here. So I never know what to call this. I read it as ASP Rocks because I was an ASP developer for a number of years, but I've heard it called ASPROX. But this was a botnet, right, back in 2008, more or less, that used some interesting techniques to inject malicious JavaScript into many websites, right, that ran Microsoft SQL. So one of the payloads that we pulled here is an example of what it was injecting. So just real quickly here, so you'll notice a series of semicolons. Those are delimiters for what we call stacked queries. So it's actually a set of multiple commands, T-SQL commands, that were executed in the SQL context. So the query engine actually processed that when this botnet activated. So what this query does is set up a temporary variable of varchar and injects a hex-encoded piece of JavaScript that, when rendered back to a browser that visited this website, okay, and the website was rendering back data values from the database. So if, for example, the payload would get injected into any and all varchar data type fields. So you visited a website that was infected, your browser would render this JavaScript and execute it and install a piece of malware, which I believe was like a spam bot of some type. So the interesting thing about ASP rocks, I'm going to stick with that title. So the interesting thing are these points. So this obviously relied upon the database's capability of executing stacked queries in the context of the vulnerable web application page. It also relied upon the fact that the database tables were updatable. It used hex-encoded JavaScript. Sometimes you use that to compact your payload. Other times you use it to obfuscate it to get around filtering or any type of security monitoring. It spread through the visits to quote-unquote trusted sites. So back around this time, the attackers were no longer as much trying to get users to visit malicious sites as they were infecting trusted sites and letting it propagate through that attack vector. And then also it obviously relied upon the fact that the web application was some sort of database-driven app or pulled information from database queries. So this talk is actually presenting a set of methods to use SQL injection in such a way as to exploit the vulnerable website. Let me back up. So we are only going to be requiring the last two bullet points, okay? And we'll talk about why that's important later on in the talk. So we'll just on with the show, right? So the case study, again, was based on a real-world penetration test. The web application in question was live. It was accessible from the internet. It had username and password, like a login page for authentication, and actually a web page that unfortunately did not require authentication to pull or to perform certain functionality. And when we exploited it, the client was like, "Oh my God, I can't believe we have this on our network. Please, give us more information. We want to remediate immediately." Expected more reaction from this slide, but too soon, right? Okay, too soon. Okay. So, rather than talk a whole lot about what this application did or whatever, this is in essence what the web code looked like. So it was an application pen test / application code review. So we actually had access to the source code, and this is what it looked like. So the top part is actually a page load event, and it calls the support and get image data function at the bottom. So can anybody spot the vulnerability? Line 36, thank you. So exactly, so you're taking input, which was supplied by the page load handler. You see at the actually line 16, we're passing request query string get image ID, eventually down to the function as a string. Now, image ID, you would think that should be a numerical value. Why in the world did they treat it as a string? Who knows? But they did. And as you can tell, the query just happily appends it, or the code happily appends it to the query string, and the SQL data source, or the command object, happily executes it. Now, a couple things about this code. Yes. Somebody? Yes. C#. This is C#. Mm-hmm. So a couple of things, interestingly, maybe not interesting, but important to point out. Number one, that the content type of this web page is fixed. It's application PDF. And the reason that is because this is like a get file web page that returns only PDF documents. So the essentially the web page, the purpose of the web page was to retrieve a stored PDF within the database. It was like the image or binary data column, and given a unique ID, would pull that the stored PDF from the database and return it as a web page, which since the content type is application PDF, the browser would automatically render it as a PDF. So, and then the other thing to point out here is that it issues the execute scalar method, and what that does is, if your query, for example, returned more than one row set, right? Execute scalar would actually only return that first row. Was that done on purpose? I'm not sure. But what it also does, from our research, it indicates that you cannot do stacked queries. Okay, you cannot pass stacked queries to this particular web page, or you cannot inject stacked queries here. So remember that for later. It'll come back to it'll come back up for discussion, hopefully. So this is the application performing as designed. So obviously the developers meant that the parameter be an integer value. And actually what it was is you logged into the web app and you would be presented a list of links. These are the documents that are available. You click the link, it would go directly to this URL and render the doc. Okay? So the problem with tools is, well, first of all, this was an application code review, so we did use some automated testing tools to identify, hey, security analyst, this application accesses a database. It probably is vulnerable to SQL injection. Thank you. But I actually just identified it manually, right? So it's pretty obvious that it had a problem. However, using other automated tools to try to validate that finding, that's where it was a little more interesting. For example, there's a well-known tool that tries a number of different attack vectors related to SQL injection to try to pull usernames, database names, table names, column names, actually extract the schema from the database. That tool actually failed. And the reason that tool failed, and actually I ran a few scanners on this model web application, the scanners actually failed. And the reason they failed to identify clearly the SQL injection vulnerability is because they had no way of parsing the response from the application, since it was in essence a binary response, right? It was not HTML markup, it was application/PDF, right? So that was one reason. Another reason, I think I ran SQL map on it, and it seemed to work fine for a few iterations of blind SQL attempts, but it seemed to choke after a little bit, and I think that parsing had something to do with it. So I'd like to take away from all of this slide to be, as penetration testers or attackers, we need to not rely so much upon these great scripts that are already out there, but sort of use our heads and our brains and our skills to move past these tools when necessary. Because if you can imagine, okay, so we had a blind SQL injection vulnerability. If we use some sort of tool to iterate through queries that compared, true/false values or responses one character at a time, it would take it forever to get the data that we were after, right? So we felt that there was a much better way. We wanted to tweak that query, but unfortunately the tools didn't allow sufficient tweaking to do what we wanted. So this is basically our custom payload for this particular website. So what we did here is, of course, null out the expected parameter value. So that was necessarily, I guess that's a typo here, but image ID equals, okay, let's ignore what it's supposed to be, make that a false condition, and then union all will append another result set to that initial query, right? And we can extract pretty much anything that we want from that database. So we had to use union all instead of union because the original data type of the column, right, was image. And when you use image or binary data types, SQL wants to, actually SQL will prevent you from doing unions with even another column of binary or image data type. So union all kind of gets around that restraint. And then also we used convert, or we could have used a cast here to actually return the row set that we wanted from the database as varchar. And actually what that forced the command processor to do was to return it as readable text. Otherwise it would have been a hodgepodge of text and binary data. So hopefully this will become maybe a little clearer as we move on. So here's just an example of using Burp to send a custom payload. Basically, it's our template that we just saw. And the payload here that we used in this case was at version. So we asked the database to return information about what version you're on. And as you can see, it renders fine in the proxy, right? This would not render in a browser. Why? Because the application content type is PDF. Okay. Make sense? So that's kind of really boring, right? So why not pull data from the users table? So since this was an application code review, I knew what columns there were, but we could have enumerated those through blind injection of text too. But as you can see, the payload at the top, we are using a little bit of SQL Server, Microsoft SQL Server support for XML, and so we're stuffing all of the rows, right? We are stuffing concatenated values from the users table, and we're doing a little trim to make it a little more condensed here at the bottom. So we're again pulling username and password, and we use a delimiter as well to make it more readable, and that's what we get, right? So you can imagine how much time that might have taken using the blind SQL injection approach. Here it returned within a few seconds. So is this new to anybody? Does this make sense? So hopefully nothing surprising here. In the real world app, actually they did not store their passwords in clear text. They used hashes. But they were unsalted, so that was actually the least of their worries. Yeah. You know, in most of the pen tests that I'm involved in, they are usually integrating with LDAP or some type of directory service. And yeah, so we actually have no visibility into, a lot of times no visibility into how they're storing it because they're using another data store. But when it is brought sort of in-house into the application, I would say about 50%. Yeah. Yeah. So the real-world application had major problems, right? Because not only could we pull from the database, we could write to the database. Okay, the tables were wide open. The SQL Server service account was network service, I believe. Might have been local system. I have to think about that because we were actually able to use some tricks. Well, not tricks, commands in SQL open row set to read from the file system. So I think in the final report, I was able to show a screenshot of the boot INI file, okay, which was kind of surprising to them. What else? So major ownage, right? So we could actually execute XP command shell, upload a web shell to the web server, get root access and all this. So why wasn't that good enough, right? Well, we wanted more, right? And the reason why we wanted more wasn't, at least in my mind, I can't speak for your mind, Kristov, but well, what if the web server was hardened? What if those tables were read-only? You know, what could an attacker really get away with, or do to make the application respond in the way that he or she wanted to. So something, you ever get that spidey sense, that you know that there's something else out there? That's kind of what I had with all of this. So what could an attacker do in those situations? Okay, so we're kind of transitioning from the live application into our demo app. Okay, what could an attacker do? In fact, any of this will apply to that live demo app. But I'm going to hand the mic to Kristov. He's going to run through a few things.
So, since we were dealing with an application that was returning a PDF as a return type, we started to look at what can you do with PDF. There's a lot of great research out there about malicious PDFs. So the syntax for a PDF, very forgiving. You can mangle all kinds of stuff, still get it to render in your reader. A lot of that is client or version dependent, but there's all kinds of stuff that you can leave out or modify. There's lots of great obfuscation techniques. Again, lots of great work on there by Didier Stevens and others. You can encode stuff in hex and octal, add white space. You can encrypt it, all kinds of stuff. You can nest a PDF inside of another PDF. So there's all kinds of stuff that you can do with PDF that's interesting for an attacker. So we basically started to look at, all right, so we're able to inject stuff into this data stream about what's being returned back to the user. It's a PDF. What can we do with that? And I think there's sort of three sort of categories of things that we came up with. One is that you can put JavaScript in a PDF. If you can return a PDF that's going to be rendered in your browser or reader or whatever, it can run JavaScript. So you can do all kinds of cool stuff with JavaScript, including malicious payloads and stuff like that. Aside from JavaScript, you can inject stuff into the PDF content stream in other places as static text or hidden text or whatever. And that can include, the result of database queries, which you could also do with JavaScript as well. And of course, you can replace the whole thing that's being returned with just a PDF, a raw PDF. Again, including malicious PDFs. So let's do some demos of some attacks that we illustrate this. Yeah, I'll just stay here and you can do that. So we have a little test server set up. Again, it's running that code that you saw, running on a Microsoft server with MS SQL in the background. And the first attack that we're going to show you is one in which we're injecting something into the content stream of the PDF, where we're actually it's going to be injected into the text of the PDF. So when the PDF pops up, you'll see some text, and we're returning some database values. So earlier, Shawn showed you an example of when he was performing this SQL injection attack. He grabbed some data from the database, some passwords and usernames and stuff like that. And what we were able to do is actually create a valid rendering PDF in which that stuff is presented to the person looking at the PDF, just to demonstrate, hey, we can return a valid PDF, and it can have these database queries in it. So we wrote a quick tool called SQL Squirrel. We'll give you a link to the tool at the end. And what it does is you give some different options, and it generates one of these attack URLs demonstrating these different kinds of attacks. So this is generating one of the URLs. Shawn's going to grab all the payload after the image ID stuff, and he's going to paste it into the browser for the test environment. And the tool itself can perform a variety of different kinds of attacks. But currently, the tool, all of the attacks that the tool is performing are based on returning a PDF. In the future, we'll be looking to extend that to other kinds of content types as well. So he's opening up just a standard use of the application, which returns just a normal document, and now he's going to perform the SQL injection on it at the end there, after he gets rid of the other equal sign. As you can see, it's popped up in the reader, and we get a JavaScript pop-up that got the admin credentials. And if Shawn were to change the ID at the end to 2, you'd get the next user in the database, in that database. Joe's not very creative with his passwords. So that's a demonstration of the tool. The rest of them we're just going to grab from our notepad. The next attack that we're going to demonstrate is was it the JavaScript pop-up? No, it's putting it into the content stream, right?
No, it's
the redirect. Sorry, yeah. So the last one that you saw, JavaScript pop-up. The next one is another JavaScript-based attack. This is actually using the JavaScript in the PDF being rendered to redirect the reader window to another URL. So it's not a browser redirect. It's coming from the PDF. ihacks.com. ihashacks.com. All right, cool. Got one or two more for you. So you notice this one's a bit longer. We'll talk about what's going on there, but basically it's creating some text in the actual PDF instead of a little JS pop-up. Again, it's returning these database credentials, these credentials being pulled from the database, and you need that extra syntax to get it working. But same thing, but it's text validly rendered in this PDF. And then this last demo that we have for you, we're gonna pop some calculator. So that looks pretty long, but it's actually, we put a bunch of work into reducing the size of it. So I'll talk about this a bit later on, but there are some restrictions in terms of how large your payload can be depending on what kind of requests you are submitting. And this particular exploit is a modified version of an exploit from the Metasploit module. It's the util printf exploit for Adobe Reader. We're actually, in the demonstration, we're using Adobe Reader version 8.1.2, I think, for the specific purpose of demonstrating this calc popping exploit. There are, of course, other more recent versions of Adobe Reader that have exploits for them, but the payloads are much larger, so that's why we decided to go with this one. We popped, what's that?
Live demos.
Yes, live demos. Living on the edge. So we just popped 2 calcs because we're just that awesome. Yeah. One wasn't good enough. So now you know that we're doing something interesting and useful with that. So let's just talk a little bit about what's going on in those payloads. So here's a JavaScript payload. And what this is doing is it's going to just pop up with an alert box. You can see app.alert, and it's just going to say stuff goes here. That's where your payload would go. In fact, if you're using the script, you get to say what goes there. And just to talk briefly about what we're doing for encoding. So this is a GET request. So all the spaces have to be encoded as pluses for it to be a valid GET request. That also means as a result, that all of the concatenation operators in SQL, which are a plus sign, have to be URI encoded so that they're not confused by the web server. And one other encoding that we had to do for this is that since we're attacking a .NET based system, .NET has a cross-site scripting filter that's included. So anything that looks like a script tag or any kind of tag, HTML tag, that will get parsed out. So you have to insert a space after the less than symbol. So you'll see that in various places here, and we have to replace it with a plus because of the get request. Did that make sense? Yeah. All right. One other payload to look at. So this one, like I said, this one's a bit longer, but basic idea is that again, we're just putting some static text in the PDF in the payload part. And all this stuff setting it up is just saying, okay, reader, this is going to be some text. Here's a little box inside the PDF. This is actually a post-based request. You can tell because there are spaces in there. And again, that the plus signs in the SQL stuff are not URI encoded. Here is a way of passing in a base64 encoded string as a PDF. So we're using an XML based element to say this is a base64 binary. You can also do a hex encoded string there as well, and you're passing in a base64 string. Now what's interesting about that to me is that before we were talking about, okay, you can do all this PDF obfuscation, right? You can insert, white space, encrypted, all this other stuff to mess with your AV, right? Now you're combining that with SQL-based obfuscation, and this is one example is base64 encoding the string. So how many IDSs out there are not only looking for something that's going to have all this PDF obfuscation, but then is also a base64 encoded string that's going to be rendered back as a regular PDF when the user clicks on the URL. Not very many, so I think that's pretty cool. Shawn, you want to talk about the implications?
A few notes on this last slide. So this is actually XQuery, and that was something introduced with SQL 2005. So just to note that won't work on SQL 2000. So thank you, Microsoft. Okay, so implications. What does this mean? What's the relevance? So we thought of maybe two or three cases, right? So data exfiltration being the first one. Okay, what can an attacker do? Let's present the scenario where an attacker is interested in some data that's within the network, okay? And the target is a user of that application. So we assume it's an internet application that is accessing internal data of some type of sensitivity, right? It could be credit cards, it could be PII, could be credentials, whatever. So the attacker might use social engineering techniques to get the user to click the malicious link that they sent to that user, right? And obviously the link would have our payload or a payload of that type that we just demoed. A special note that the payload is actually not stored anywhere, right? It's fairly virtual, or it's to the effect that its context is inert when it's passed, right? Until it's processed by the web application. So the user would click that particular payload, right? The query would execute, and for example, say the attacker would want the data rendered into the text box, content stream, whatever you want to call it there, but might prepend a bunch of spaces, or he or she may format the PDF framework around the query results in such a way that the results are not shown within that nice little white space that's rendered in the browser. Okay, and the user says maybe there's something wrong with your link. I'm only seeing an empty document. I'm sorry, I can't grant your request that you asked of me. And the attacker may say, just go ahead and send me that PDF anyway. I'll take a look at it and we'll kind of figure it out. And that may be one attack vector, right? So data exfiltration. There are ways to maybe munge with the data results. So SQL can, we saw how SQL can decode base64, it can also encode. And there are a number of ways that you can do some sort of exfiltration, obfuscation to obtain that information. Perhaps the more interesting use case is the malware delivery. So the attacker may not give a care about what's in the database, okay? Or the database just may not be available for data exfiltration, or the data is of no interest. Maybe the server's hardened in every other way other than it processes T-SQL commands when injected like this. So, so the attacker may opt to target this particular web application to deliver malicious payloads, right? So, anybody have any other use cases? I'm kind of curious to see if we missed one. I'm sure we have. Yeah. So the joke was that we could have delivered this nice report page to the client by rendering it from the web application itself. So, yeah, exactly. Yeah, here's your report, and yeah, exactly. So, but that also brings up an interesting point. So the actual PDF payload could be of sufficient content as to present a PDF form, right? So you can have form fillable PDFs that prompt for credentials or maybe mimic an existing PDF that's out there, and you can also inject JavaScript that might send that information that's typed into the form via email, via other channels, right back to the attacker, right? So PDF is really nice. There's a lot of functionality that we could potentially exploit. So one other point related to implications. So, how many web reports have you written or have you seen where it says, you have a SQL injection vulnerability, you need to fix it, and by the way, your website can proxy malware requests. You just don't see that, right? And I've personally been involved in pen tests where I've come across SQL injection, but when it was reported up the chain, the management or application owner said something, to the effect, yeah, we understand, but it's locked down. There's nothing of importance, or it's locked down. The user is not a privileged user. You can't really execute a command shell or anything like that. So, you did. Interesting. Persuasive sort of personality, I guess that's what I'm trying to say. So yeah, interesting. Yeah, and unfortunately, a lot of developers get very protective of their code, and we want to be respectful of their jobs and everything. In essence, as penetration testers, we want to benefit the client by bringing up vulnerabilities so they can be remediated. So speaking of remediation, there is an important part to mention too. So although we can do all this neat PDF acrobat maneuvers here, so the root cause is still the same, right? You've got SQL injection in your website, you can fix it. So, and we feel that's important to call out in more or less what the finding is, right? But the impact is what may be different. So, it really depends on the application, right? If it's locked down in any other way that as a pen tester, maybe you have a relationship with the client that, they're going to push back, right? Maybe we can call that out a little further. Not only do you have SQL injection, but do you really want to go, into court or whatever to be a third party to a hack or something like that? So, and some would say, yeah, take the risk. So right now, obviously we just presented attacks that target Microsoft SQL, ASP.NET, but we can adapt to other database syntaxes, so Oracle, Postgres, Informix, whatever, PHP. So, and obviously, we did a pop calc, but as long as your payload is a sufficient size, you can do it through get. You can do it through post if the application accepts that collection, the post collection. And then also PDF. Well, we picked a lot on PDF today, right? But we can actually format it in any really type of open format, right? We've got a working exploit against PostScript, and actually there's several out that were results of research. So PostScript will actually execute JavaScript as well. So. Right. So yeah, exactly. Yeah, nice. So I think there was a talk like how not to let your applications review themselves or something like that. How not to let your applications write their own security reports. So, okay, Kristov. Got it? Yeah.
So I mentioned earlier that there are some limitations they have to deal with this type of tech. The most important limitation is if you're trying to do this over a GET request, trying to paste something into the URL, you're going to have some size limitations that come up. It turns out that the one that's the sort of the most restrictive is for Internet Explorer client. So Internet Explorer after the path, it only allows 2,083 characters in the entire URI. So that leaves you with not a whole lot of room to generate a PDF. Now, you obviously have some alternative options available to you. If that's not viable, you can target other browsers. There are some web server restrictions that come into play after IE, but they're bigger. If you are able to do this over a post request instead of a GET request, the limitations are, it's a much larger maximum size than for GET. That may require some additional vulnerabilities in the site that you're targeting, like a cross-site scripting vulnerability. And but if you just want to make sure that this is a universal attack, there are some basic things that you can do to try and reduce the size of the payload. You may have to get rid of some of your PDF obfuscation stuff because they tend to blow up the file real fast. When I took the default thing that was coming out of Metasploit, they had all kinds of encoding going on, and it's good for obfuscating the PDF and avoiding AV detection, but they really make the file much larger. So you're looking at things like JavaScript optimization if you're using a JavaScript-based attack. A little bit strange thing about that is instead of trying to optimize it for speed, which is what you would typically be doing for JavaScript, you're now trying to optimize it for size. So there are different ways to encode or not encode the file to reduce the size to get around that restriction.
And by the way, I think we failed to point out that on that XP box we did have AV enabled in the decimal current, so it slid right by it, right? Surprising? Not really. So the obligatory defense slide, right? So nothing too surprising, hopefully, for anyone here. So on the application side, we want developers to really mitigate or prevent these types of attacks by filtering untrusted input, encoding output, blah, blah, blah. Encoding output a little different in this context because what they're dealing with application, the content type of PDF, so they have to support certain characters in the output. But the input, they certainly could have filtered much more effectively. You can do that a number of ways. You can assert that the data type coming in is int instead of string. You can do bounds checking. You can do parameterized queries. They should do parameterized queries, right? So on and on. It really depends on the nature of the app as to how many protective measures the code needs to implement. User training. Why don't we just do user training? That's effective, right? I had to put it up there. So obviously, if they didn't click the untrusted link, this really would slim down the attack surface. I mentioned WAF and network IDS as a potential effective mitigation control. So you potentially have a web application that's pulling from databases and They have parameters that are dynamic, right? So the WAF, for example, can be configured to look at all requests with this particular parameter name and ensure that it's a numerical value for each instance. And that would be effective at blocking this type of attack. And there's other ideas. If you have any, shout them out. So yeah, for further reading, this is a number of references that we used in our research. And if you would like to know more, or if you haven't visited some of these sites, we encourage you to do so. Again, not SQL 101 necessarily, SQL injection 101. This is more the what I find more interesting, having been a database developer for a long time. So more of the advanced stuff. The third one down, the SQL injection cheat sheet. It's an awesome resource. It covers MySQL, MS SQL, Oracle, probably a few more. Is organized very well, and it's a go-to source for me when I do pen tests. The last few have to do with content sniffing. So, for example, if you're a vulnerable web page, instead of returning content type of PDF, maybe it's open to tampering, or maybe it's like octet stream. You can actually exploit the feature of IE, which sniffs content, and you can potentially render otherwise inert strings as, for example, JavaScript. Okay, and that's how we could potentially use our payloads to, for example, execute cross-site scripting attacks or some of the other document formats. Okay, and there's more, right? So this is more a set of good resources on PDF formatting, what you can get away with, how to trim PDFs, what's really necessary. Again, Deidre Stevens, Julia Wolf's got a great couple of resources out on FireEye about PDF formats. Awesome resource there. And that's about all I have to say about that slide. And we found a graphic for our tool, so we hope you like. So check out the script, make comments. I think that's a capability out on GitHub. We've got contact information out there. So if you can think of other use cases or features you'd like to see, we'd be more than happy to build those into the script. So, any questions? Yeah. Sure. Right. So yeah, and if I could paraphrase, so the question was, what if parameterized queries aren't an option? Or if it's a preference to handle some of the assertions of data type or bounds in code rather than using parameterized queries? I don't think it's stupid at all. In fact, I see that all the time, where even if it's a SQL Server backend, I see all the time where developers do that very thing. And as long as you are consistent with that, so if the code is maintainable and you can audit periodically that somebody else hasn't gotten it in there and change things, for one, there's probably a ton of other scenarios to consider, and if your controls are effective. So I would encourage, if that is in place, to make sure you're doing those the code reviews and pen tests, just to make sure that, number one, you haven't missed anything, and number two, maybe there's a new attack vector out there that came out last year. Do your controls still work? So, yeah, good question. All right. Well, thank you for your participation and attention. Thank you very much.
And we have a 2012 copyright malware analysis book. Yeah. Cool.
Awesome. Thank you.
Oh, by the way, that also escapes VMware.